let us continue our discussion on constructing push-down automaton for languages. Consider this language. It is set of strings x. X belongs to a comma b star, such that if you look at any string x, x contains equal number of a's and b's. So number of a's, if you see, is same as number of b's. Fine. So that's precisely our language. Now let's see how to build an automaton for this. We know that this one is not regular because a power n, b power n is a special case of this language. A power n, b power n has equal number of a's and b's, which is non-regular. Therefore, this language, which is a superset of a power n, b power n, is also non-regular. Now let's see whether the additional feature, which is stack or push down store, is helping us in building an automaton for this. So idea is this: the input tape contains A, and the top of the stack is Z0, then we perform push. Similarly, if it is B and top symbol is Z0, then also we perform push. Suppose the input symbol is A, top symbol is capital A, which is corresponding to small a. Somewhere before we have read a small a and pushed a capital A onto the stack. If this is the case, we continue to perform the operation, which is push. Similarly, if it is B and the top symbol is capital B, which means somewhere before we have read small b, then we push. Then when do we go for a pop? We look at A and top symbol is B, or we read a B, top symbol is this, and in these two cases we go for a pop. What is this telling us? Currently I am reading A and top of the symbol is B, which means for this A there is one corresponding B, or for the B that we have stored, we are currently reading the corresponding A, perform pop. Similarly, for the A that was stored onto the stack, currently we are reading a B, perform pop. So when you see this match, we perform pop. In all other cases it is push. Now at the end of the configuration, supposing input tape is empty and stack is also empty, or stack contains the top symbol Z0, we say it is a valid string. In all other scenarios, we say it is invalid. Fine. So let's formalize this. So delta of Q0 comma input symbol is A and top symbol is Z0. In this case, we say Q0 comma perform push, it becomes A Z0. So delta of Q0 comma start symbol is B and top of the stack is Z0, we say push B, in the sense that through this symbol we remember that we have read small b before. Through this symbol we remember that we have read A before. So we don't explicitly store the count. Instead, for every A we read, a corresponding capital A is stored onto the stack. If you ask the machine, can you tell me how many A's have been read so far? Machine cannot answer. However, machine remembers how many have been read in this form, so that if you see a corresponding sequence of B's, one will be able to pop and answer yes or no. Okay. Now let's look at the next one. Now I am in Q0. Let's assume I have seen A before, which means before this operation it was A, which is why top of the stack is A. In this case, what we do, we say we push A. So this A is the one that is inserted now, and this A is the one that was before. Okay, so top symbol and top minus 1. Now I am in Q0. With respect to A, everything is done. You are in Q0, you are reading a B, top symbol is also B. Then what do? We say Q0 comma BB. Okay. So it's precisely this. Now staying in Q0, what all can happen? You may be at the start, which means input symbol could be AB, top symbol is Z0. So that's taken care of. So once you go through this, then you are in a state where top symbol is A or top symbol is B. Accordingly you decide. If top symbol is A and input symbol is also A, perform push. Top symbol is B, input symbol is B, perform push. Okay. Now let's look at this part. Delta of say Q0 comma, I read small a, but now stack contains capital B. In this case, we say we want to perform pop, so we write like this. So this means pop the top symbol, which is B here. So what is this telling us? We have read one A, or the A that we are reading now is the corresponding A for this B. Okay, there is a match between this A and B. Delta of Q0 comma, we read a B, top symbol is A, which means perform pop. Fine. Now everything goes smooth. Let's assume we are in Q0. We have exhausted the input tape, so which means it becomes epsilon and it is Z0. We say that we reach a final state. So if you reach the final state and you don't disturb the stack, such a thing is called acceptance by final state. Or you can also do the same thing. You can go to QF. You can also empty this. Okay. Or you can also stay in the same state, Q0 comma epsilon, which means Z0 is popped out. Either you stay in the same state and empty the stack, even Z0 is taken out. This is called acceptance by empty store. Emptying the stack or emptying the push down automaton. Fine, so both are correct, both are equivalent. Either you reach the final state, don't disturb the stack, or you can reach the final state and empty the push down store or stack. You can stay in the same state and empty this. So which means when you come to this configuration and finally when the stack is also made empty, you say that automaton stops and accepts the string, and such a acceptance we call it as acceptance by empty store. Or if it reach a final state, we say the string is valid, we accept that, we call it as acceptance by final state. Now if you notice, you see that A Z naught, B Z naught, A B B, and A B B A epsilon Z naught. Fine. So if you look at this part, for each of them, Q naught comma A Z naught, there is only one move. Q naught comma B Z naught, there is only one move, and Q naught comma B A, there is only one move. So it is clearly deterministic in nature. Fine. So every transition is taken care in this. Now you see that transition function is from Q cross sigma. Sigma will only handle AB. So when you write, you should write Q cross sigma union epsilon, because we also take this into account. And earlier we wrote Q cross sigma cross gamma, but it should be actually Q cross sigma union epsilon cross gamma. Gamma contains Z naught A B. And where do we go to? We map to Q cross gamma star. So it could be epsilon, it could be just Z naught, or it could be a string like B Z naught, and so on. And the beauty over here is, with just one state Q naught, we constructed a deterministic mission accepting this. Fine. So always discover a logic like this. See under push what configuration, under pop what is the configuration, and then map that to a formal specification. Now what we did, similar to the previous example, one can construct an equivalent transition diagram as well. The next language for discussion is this: A power n, B power 2n, such that n greater than or equal to 1. So what this says is, strings of the form ABB, AA followed by 4 B's, they are all part of the language. So number of B's read is twice the number of A's. Fine. So when we read A, what task that we should carry out so that you can match with this? Remember, this count is 2 times this count, and so when we push a symbol for A, so we should carefully do it so that when we start performing pop from this place, we should be able to say that the number of B's is 2 times the number of A's. So what I do is the following: when I read A, I push 2 A's. I push AA onto the stack, which means at the end of reading this n A's, so A power n is translated into, for the first A 2 A's, for the next A 2 A's, like that you have so many. How many will be there? There will be 2n A's will be there. Now when we start reading B, you can associate 1 B with each of them, and if they match, then we can say the string is of the form A power n B power 2n, otherwise we say no. Fine. So let's map this to the formal representation. Q naught comma A comma Z naught is mapped to Q1 comma AA Z naught. So this is the 2 new symbols we push. This is already there, Z naught. Now which is why I said there are case studies where we may push a sequence of symbols, a string. So here is an example where a string is pushed, not just a symbol. Now we are at Q1, we read a small a, top symbol is A, which means we continue to stay at Q1 and push two symbols, and this is already there on the stack. This is push, this is already there. Now at the end of this, we have completed reading A's. Now we start reading B. Top symbol is capital A. Perform pop. So continue to stay at Q2 and perform the pop operation. So this takes care of push and this takes care of pop. And the end of this, we are in Q2. Input tape is empty. Stack contains Z0. You reach the final state and accept, or you can also empty the push down store and accept, or you can stay in the same state and empty the push down store and accept the string. Fine. So now this clearly tells you that a power n, b power 2n can be represented using these two push followed by pop and accept. Fine. Like the way we did before, if you find a b, there are other transitions, right? Delta of q0 comma b comma z0, we should go to a reject state. Fine. Similarly, we are in Q2. When we are in Q2, we read small a, and the top symbol could be A. Then also we reject, or it could be Q2 A and Z0. We reach the reject state. So like this, the missing ones, we reach a state called QR. That says the input string is invalid. Fine. For the same thing, one can also do the following. When we read A, we perform push, but push only one A. When we start reading B, what we do, for the first B, we do nothing, neither pop nor push. So simply skip and then go to second B. Second B we pop. Similarly, third B we do nothing, fourth B we pop. Every second B we perform pop operation. So at the end of it, you would have done n pops if there are 2 NBs. That way also you can conclude that the given string is valid and of the form a power n b power